Dear colleagues, our research team presents a study titled Gamification of Electrical Engineering Education, Development of an Educational VR Simulation. The authors are Tatiana Sliverstova, Taras Khudny, Valery Kuznetsov, Vitaly Kuznetsov, Viktor Kovalenko, and Petro Upsky. As you know, in traditional electrical engineer education, students often face difficulty understanding abstract concepts like current flow, electromagnetic fields, or circuit behavior. Access to physical lab equipment is limited in many institutions due to high costs or logistical constraints. Moreover, safety concerns prevent students from performing real high voltage experiments. As a result, motivation and engagement decline, especially when learning feels detached from practice. Our project explores this issue by implementing a gamified virtual reality simulation that combines interactivity, safety, and immersive experience. The aim of our project to assess how effective gamified virtual reality simulation can be enhancing their learning experience in electrical engineering. To achieve this, we set out several objectives. First, we integrated mechanics such as points, levels, and rewards into a virtual reality environment to make learning more engaging. Second, we focused on improving students' motivation and involvement to provide an immediate feedback and personalized progress tracking. Third, we designed the simulation to replicate realistic lab scenarios in a completely safe, immersive way, allowing students to experiment freely without the risk of physical equipment. And lastly, we gathered feedback from users and evaluate learning outcomes to understand how the tool impacts performance and retention. Gamification concept. Gamification means applying game design principles to non-game context, in our case, to electrical engineering education. It includes familiar elements like points, levels, badges, and progress tracking, which are commonly found in video games. These mechanics encourage competition, reward efforts, and give students a sense of achievement. The idea is simple. When students feel like they are playing and progressing, their motivation increases, engagement grows, and so do learning results. We used this principle to create the environment when learning feels rewarding, interactive, and fun. Virtual reality in education. As you know, virtual reality in education offer immersive and interactive environments where students can learn by doing, not just by watching or listening. In electrical engineering, virtual reality can simulate dangerous or expensive lab experiments in a completely safe and controlled space. For example, students can interact with virtual circuit boards, meters, and tools without the risk of electric shock or equipment damage. This approach also reduces infrastructure cost, as there is no need for multi-title physical workstations. At the same time, it increases accessibility for students who can practice remotely or repeatedly until they master a skill. In short, virtual reality brings practical, hands-on experience to students anytime and anywhere without the usual limitation of space, cost, or safety. Core gamification elements. Here are core gamification elements we have implemented it in our VR simulation. Firstly, points. Students earn points they correctly completing tasks such as wiring a circuit or diagnostic a fault, encourage precision and accuracy. The second is levels. The simulation is structured into progressive levels of difficulty, guiding learners from basic concepts to complex scenarios, fostering a clear learning pathway. The next, the virtual budgets or certificates are awarded for milestones like Circuit Master or Safety Guru, recognizing student achievement in an engaging way. And fourth, progress tracking and feedback. A real-time dashboard displays performance, highlight rewards, and offer personalized feedback, helping learners adjust to improve continuously. These mechanics, points, levels, badges, and real-time feedback not only gamify the experience but also reinforce learning through recognition, challenge, and visibility of progress. Features of VR stimulation. Our VR stimulation offer a range of features designed to enhance learning in electrical engineering. First, it provides immersive hands-on interaction. Students can manipulate switches, connect sockets, and observe system responses as if they were in a real lab. Second, it faithfully replicates real electrical setups, including instruments like multimeters, transformers, and control panels, giving learners a near authentic experience. Our major advantage is safety. The simulation allows students to work with high voltage or fault-prone scenarios without any physical danger, which is crucial in technical education. Additionally, the simulation supports adaptive learning. Tasks can adjust in complexity based on the student's progress, from basic wiring exercise to advanced diagnostics. Finally, students receive instant feedback and can track their performance through a built-in dashboard, encourage self-assessment and continuous improvement. Personalized learning and analytics. One of the key advantages of our VR simulation is integration of personalized learning and analytics. The system uses adaptive learning paths, adjusting the complexity of tasks based on each student performance. Beginners get more guidance and simple tasks, while advanced users face more challenging scenarios. Built-in artificial intelligence algorithm analyze student action in real time and provide contextual feedback. For example, highlighting mistakes in circuit assembly or suggesting a more efficient solution path. The platform also collects real-time analytics, time spent per task, error frequency, learning pace, and engagement levels. These data can be exported or integrated into institutional learning management system, giving instructor deep insight into individual and group progresses. As a result, instructor can take data-informed teaching and decision, who needs supports, what topics to review, and how to optimize instruction for the whole group. Expected outcomes. As a result of implementing our gamified VR simulation, we appreciate several important outcomes. First, student motivation and engagement are expected to increase due to the interactive, game-like environment and instant feedback. Second, students should gain a better understanding of complex electrical engineering topics, thanks to the immersive and visual nature of virtual reality. The simulation also enables safe, hands-on practice with potentially dangerous or costly equipment without the risk associated with the real hardware. Moreover, the approach helps reduce the need to expensive physical lab infrastructure, making training more accessible and scalable. Finally, the system provides data-driven insight into student learning, which can be used educational to evaluate individual and group performance and continuously improve teaching strategies. These visuals reflect what we expected from our VR-enhanced electrical engineering simulation. First, VR training is known to cut learning time by up to 40% and increase engagement by nearly fourfold, while knowledge retention can grow by 275% according to the industry data. In laboratory-like VR sessions, students actively manipulate virtual equipment, gaining practical experience without real-world risks. These not only enhance motivation and understanding or complicated electrical system, but also remove the need for costly hardware, making training scalable. Finally, with analytic tracking engagement, task competition, and performance, instructors gain valuable data-driven insights to optimize instruction and support each learner growth. And uh, in this slide, we have conclusion and future work. In conclusion, our project shows that combining virtual reality and gamification offer a powerful way to modernize electrical engineering education. This approach not only increases student motivation and engagement, but also allows for safe, interactive, and repeatable hands-on practice. Thanks to built-in analytics and adaptive learning paths, instructors can personalize training and rely on data-informed decision to support each learner. As for future work, we plan to conduct pilot implementation with students to test usability, engagement, and learning outcomes. Based on feedback, we will refine the system, expand simulation content, and explore integration with learning management system platforms to ensure smooth adoption in real education settings. Thank you very much for your attention.